Hello everyone, welcome to today's class. Our topic is measurement of heat energy. But before we start, we'll look at what heat is all about. And we'll say that heat is a form of energy that is transferred from one body to another due to temperature difference. And we can also add that heat is a vector quantity. Heat is a vector quantity. And of course, vector quantities have both magnitude and direction. Now for the direction, it is the temperature that gives the direction to heat flow. Because of that, we now say heat is a vector quantity. The SI unit of heat is joules, written as J. Now the next thing we'll look at is heat or thermal capacity, C. Okay, heat capacity. We say that heat capacity is the quantity of heat required to raise or lower the temperature of a body by 1 degree Celsius or 1 Kelvin. Now, it is represented as Q is equal to MC, where Q is the quantity of heat measured in joules. M, mass of the body measured in kilogram. C is the heat capacity. Now the next is to find the SI unit for heat capacity. Now from the expression, we can make C the subject of the formula. And if we make C the subject of the formula from this, we now have that C is equal to Q all over M. Q is the quantity of energy measured in joules. M is the mass of the body measured in kilogram. Therefore, the SI unit of heat capacity is joule per kilogram. It can be written as joule per kilogram like this. Okay. Heat capacity C is also related to the expression Q is equal to C delta theta. Delta theta is the temperature difference. So making C the subject, we now have C is Q all over delta theta. Q is measured in joules. Delta theta is measured in Kelvin. Therefore, the SI unit for heat capacity can as well be written as joule per Kelvin or joule per Kelvin. In other words, we have two SI units for heat capacity depending on the parameter given. So most times we can have it as joule per kg or joule per Kelvin. Okay. Example, a copper ball of heat capacity 400 joules per Kelvin is heated from 20 degrees Celsius to 100 degrees Celsius. Calculate the quantity of heat absorbed. Solution. The first thing we'll do is to write out the parameters given. Now from the question, the parameters are heat capacity C 400 100 joules per Kelvin. It said it's heated from 20 degrees Celsius. That means the initial temperature, theta 1, is 20 degrees Celsius. Final temperature, theta 2, 100 degrees Celsius. Quantity of heat absorbed is not given. Now, from the two formulas we have, Q is mc and Q is C delta theta. Of course, it is the second formula that can suit this problem. So because of that, we use this. Q is equal to C. In place of C, we have 400 times. Now the temperature change, which is theta 2. Theta 2 is 100 minus theta 1, which is, of course, delta theta is theta 2 minus theta 1. Now having written theta 2 as 100 minus theta 1, theta 1 is 20, which will give us 80. We now have 400 times 80. By calculation, we have which is 32,000 joules, or you can put it in standard form, 3.2 times 10 raised to power 4 joules. This is our final answer. Now let's take another example. Example 2. A metal of mass 350 grams placed in a furnace gain heat energy of 1,500 joules. Determine the thermal capacity of the metal. Solution. The first thing we do is to write out the parameters given. Now from here we have a metal of mass. The mass is 350 grams. And of course, since it's in grams, we convert it to kg by dividing by 1,000. So we have 350 divided by 1,000 will give us 0.35 kg. Okay. Now, the quantity of heat gain, Q, is 1,500 joules. And C is what we are looking for. Now, from the expressions, the first one, Q is mc, while the second one is Q equals C delta theta. And of course, the most suitable formula for this question is the first one, which is Q equals mc. Now, we'll write it here, Q equals mc. We're looking for C. Make C the subject. C is equal to Q all over M. Now substitute. We have 1,500 joules all over our mass. The mass we are using now is the converted value, which is 0.35. 0.35. And 1,500 divided by 0.35 will give us 4,000 equal to 4,800, 4285.71. Therefore, the thermal capacity is equal to 4,285.71 joules per kilogram. All right, this is our final answer. Now the third one, I'll give the third one You drop the answer in the comment section. Okay. The temperature of a piece of metal is heated from 10 degrees Celsius to a certain temperature theta. If the quantity of heat absorbed is 1080 joules, determine the value of this temperature, given that the thermal capacity of the metal is 320 joules per kilogram. All right, thank you. This is where we'll wrap it up for today's lesson. Please don't forget to like, share, and turn on your notification button for subsequent lesson. Please drop the answer in the comment section below. Thank you.